Hello, Advanced Algebra students. I hope that you are having a wonderful day. I'm so much enjoying working with you guys. You're an excellent group of students. We are continuing on in Chapter 2 of our Advanced Algebra book. We did Section 2.1 on the vertex form of a parabola, and today we're going to talk about standard form. So you need to put, and all I have on the board is just Section 2.2, standard form of a quadratic function. So we did briefly talk about this in our last notes, but standard form is simply f of x equals ax squared plus bx plus c. Essentially, we're saying that we have a function with an x squared in it, so that a cannot be 0. Now, there's a couple things that we can tell from this format. In this particular format, we can see that the y-intercept is c. And that is because if we plug in 0 for x, we get that y is c. A also means the same things that it normally does. So if a is positive, the parabola opens up. If it's negative, the parabola opens down. And then if a is greater than 1, we are stretching the parabola. And if a is between 0 and 1, we are shrinking the parabola. So that is kind of the format that we're working with. Now, the most important thing to take away is that when we have a function in standard form, the vertex or the x-coordinate of the vertex is going to be at negative b over 2a. That is the most important part to know. And then the y-coordinate, to find that, you're going to plug the x-coordinate in and solve for solve for y. Okay, so let's do an example. Just example 1, very straightforward. What is the vertex of the function? This is example 1, x squared minus 6x plus 10. And we can write that as y equals x squared minus 6x plus 10. So in this particular case, our a is 1, our b is negative 6, and our c is 10. So we know that our x-coordinate is going to be at negative b over 2a. Now since b is already negative, it's going to be negative 6 or positive 6 over 2 times 1, which is 3. So the x-coordinate of this parabola is at x equals 3. Now to find out what the y-coordinate is, we just plug in 3 for x. So 3 squared minus 6 times 3 plus 10 is 9 minus 18 plus 10. So negative 9 plus 10, which is equal to 1. So the vertex of this parabola will be at 3, 1. We used 2 steps to do that. We got the x-coordinate by using negative b over 2a, and then to get the y-coordinate, we plugged the x-coordinate in and solved for y. So that's a fairly straightforward example of how you would find the vertex of a parabola written in standard form. Now let's go ahead and take a look at our second example. So for example number 2, we're going to look at the quadratic function y equals x squared minus 4x plus 8. That's y equals x squared minus 4x plus 8. We're going to use the vertex and y-intercept to graph the function, and then we're going to label the vertex and y-intercept as well as the axis of symmetry. So in this particular case, our a is 1, our b is negative 4, and our c is 8. To get the x-coordinate of the vertex, we're going to do negative b over 2a. Can you see if you can figure out what that would be? What would negative b over 2a be? So if b is negative 4, the opposite of negative 4 is positive 4. 4 divided by 2 is 2. So our x-coordinate is at 2. To find the y-coordinate, we plug it into our equation. 2 squared minus 4 times 2 plus 8 is 4 minus 8 plus 8, which is just 4. So our vertex is at 2, 4. So let's go ahead and plot that. The vertex is at 2 over and 4 up. Now, the y-intercept is C, which is 8. 5, 6, 7, 8. So I'm going to put a dot there. And I know that this parabola goes through the point 0, 8, and I just draw the other side symmetric to that. So our vertex, we already discussed, is at 2, 4. The y-intercept is at 0, 8. Now remember, the axis of symmetry is the line that goes right down the middle of the parabola, and it's always in the form x equals whatever the x-coordinate of the vertex is. So our axis of symmetry, and we learned this from last time, is just x equals 2. So that would be a complete answer to this question. Okay, now what we're going to do is look at example number 3. We've got a total of 4 examples in these notes. We've just done the first 2. Let's go ahead and look at example 3. On example 3, we're looking at the function f of x equals negative 10x squared plus 700x minus 6,000. This shows the profit a company earns for selling headphones at different prices. What is the maximum profit the company can expect to earn? So for this particular example, what I did to make it fit on my graph is I did a graph for the y-axis. I skip counted by thousands. So I went 1,000, 2,000, 3,000, 4,000, and up to 6,000. And then on the x-axis, I skip counted by tens. So 10, 20, 30, 40, 50, and 60. Now, let's go ahead and take a look at the x-coordinate of our vertex. So we know that A is negative 10, B is 700, and C is negative 6,000. To find the x-coordinate, I'm just going to take negative B over 2A, which is the same thing as negative 700 over negative 20, which works out to be 35. So I know that I have an axis of symmetry at x equals 35, and I'm just going to put that in my graph so I can see that there. Now, that also means that the x-coordinate of my vertex is 35. So in order to find the y value of the coordinate, I need to plug 35 into my function. So I'm going to have negative 10 times 35 squared plus 700 times 35 minus 6,000. When I do that, I get negative 12,250 plus 24,500 minus 6,000, or 6,250. So my vertex is 35, 6,250. So I need to go just a little bit above my 6,000 mark on the y-axis. Now, this graph is going to go quite steeply down, but they actually don't want us to graph the entire thing. We can essentially just graph that vertex there. I believe, let me check here, but I think I did a little bit of extra work on this and saw that we had an x-intercept at 10 and at 60. Let's see if that works. If I plug 10 in for x, I'm going to have, let's see, 7,000 minus 6,000. And then if I plug 10 in there, 10 squared is 100, minus 1,000. Yep. You don't need to necessarily know this kind of detail yet, but you would get, when you plug in 10 for x, you would get 0 for y. And when you plug in 60 for x, you also get 0 for y. But the key thing to take away here is this point right there. That's, since Y represents our profit, profit will be maximized at a selling price of 35. So we can write the selling price of $35 per item gives a maximum profit of $6,250. And I believe it's probably in thousands of dollars, but you know, for the scale we're talking about, that would be the correct answer. Okay, so that was example number 3. Again, when we're looking at the maximum value for a parabola, it can be helpful to determine things like maximum profit. Let's look at our last example. So example number 4. In this example, they're asking for the equation of a parabola that passes through the points -2, 32, 1, 5, and 3, 17. Now, the way that we do this, we're going to have to use our calculators on this one, is we need to write 3 equations by substituting in the given x and y values into the standard form of a parabola equation. So we want to write ax squared plus bx plus c equals y. Let's do the first point when x is -2. So I'm going to say -2 squared, which would be 4a, and then minus 2b plus c equals, and in this case, y is 32. So that's the equation that we would get from the first point. Now let's look at the second point where x is 1 and y is 5. We're going to plug 1 in for each of our x's. So we're going to have 1 squared times a, or just 1a, plus 1b plus 1c equals, in this case, y is 5. And then for the last point, we're going to plug in 3 for x and 17 for y. So 3 squared is 9, so we would have 9a plus 3b plus c equals 17. Now, we want to come up with the equation of the parabola, so we want to know what a, b, and c are. So we want to essentially solve this system of 3 equations with 3 variables. Now, if you remember, we can write the augmented matrix for this system as 4, -2, 1, and then the 32 on the far right. And for our second row, 1, 1, 1, and 5. And for the third row, 9, 3, 1, and 17. Now, we do need to plug this into our calculator and use reduced row echelon form. So we need to enter this matrix, and I can actually kind of talk you through it. We'll go ahead and do it in class more. But you're going to push the second button and then x to the power of -1 so that you enter in your matrix, go over to edit, put in a 3x4 matrix, and then put in those numbers. So 4, -2, 1, and 32 will be your first row. And then 1, 1, 1, and 5 will be your second row. And then 9, 3, 1, and 17 will be your third row. Then you quit out of that. You do second matrix again and go over to math, and then go down to, on my calculator, it's way down there. It's number, 10, 11, the 12th thing down. It's RREF. That stands for Reduced Row Echelon Form. I'm going to click that. I'm going to pull up matrix A and then put my right parentheses in and hit enter again. And the matrix that I'm getting out on my calculator is 1, 0, 0, and then 3, 0, 1, 0, and -6, and 0, 0, 1, and 8. This is telling me that x equals 3, A equals 3, and then B is equal to -6, and C is equal to 8. So if my form in standard form is y equals ax squared plus bx plus c, and my a is 3, my b is -6, and my c is 8, the answer would simply be y equals 3x squared minus 6x plus 8. Now I know that was kind of intense. We will do more of that in class together, but I'm really proud of you for watching the notes. Thanks.